What if our universe is not the only one? Could another version of Earth exist somewhere beyond our universe? What if every decision you make creates another reality? Could there be a universe where gravity is stronger, stars never form, or life evolved completely differently? And if other universes really exist, how could we ever find them? Today, we're going beyond the observable universe to explore one of the strangest ideas in modern physics, the multiverse. Before talking about other universes, we need to understand the one we actually know exists. The observable universe is enormous. Light has had about 13.8 billion years to travel toward us since the early universe became transparent. But because space itself has been expanding, the observable universe is now roughly 93 billion light-years across. And that doesn't mean the entire universe is 93 billion light-years wide. Beyond that boundary, there may be much more universe. We simply cannot see it. Some theories suggest that our entire universe might be only one region inside something much larger. And that's where the idea of the multiverse begins. The multiverse isn't one single theory. It is a collection of different ideas that emerge from different areas of physics. One of the most famous is the many worlds interpretation of quantum mechanics. In 1957, physicist Hugh Everett III proposed a radical interpretation of quantum mechanics. Quantum particles can exist in combinations of possible states until an interaction produces a definite outcome. The traditional interpretation says the possibilities somehow collapse into one result. Everett suggested something very different. What if the wave function never actually collapses? Instead, every possible outcome continues to exist in separate branches of reality. Imagine a quantum event with two possible outcomes. In one branch, outcome A occurs. In another branch, outcome B occurs. Both remain part of the larger quantum description. This is where the popular idea of parallel universes comes from. But there is an important warning. Many worlds does not mean that every time you choose tea instead of coffee, a magical new universe suddenly appears. It is a technical interpretation of quantum mechanics, describing how different quantum outcomes could coexist in a branching structure. Another route to the multiverse comes from the very beginning of our universe. According to the theory of cosmic inflation, the early universe underwent an incredibly rapid expansion. In an unimaginably tiny fraction of a second, space expanded enormously. Inflation helps explain several mysteries about our universe, including why the cosmos appears so uniform on large scales. But some inflationary models produce a strange consequence. Inflation may not have stopped everywhere at the same time. Instead, some regions could stop inflating and form universes like ours, while inflation continues elsewhere. This creates what physicists call eternal inflation. Picture an enormous cosmic ocean that keeps expanding. Inside it, separate bubbles form. Each bubble could behave like its own universe. Our observable universe would then be just one bubble among potentially countless others. Some bubble universes might have different physical conditions. Some could contain stars and galaxies, others might be completely sterile, and some might possess different values of fundamental physical constants. But there is a major problem. We currently have no direct evidence that these other bubbles exist. This is where the multiverse becomes especially strange. The laws of physics appear remarkably fine-tuned for the universe we observe. Gravity has a particular strength. Particles have specific masses. The electromagnetic force has a particular strength. Change some of these values significantly, and stars might never form at all. Without stars, there would be no heavy elements. Without heavy elements, planets like Earth might never exist. Some multiverse models suggest that different universes could have different physical constants. Imagine a universe where gravity is slightly stronger. Stars could burn differently and perhaps live for much shorter periods. In another universe, the forces holding atomic nuclei together might be different. Atoms themselves could behave differently. And in some hypothetical universes, complex structures might never form at all. This leads to a controversial possibility. Perhaps our universe doesn't need to be specially designed to allow life. Maybe there are enormous numbers of universes with different conditions, and we simply find ourselves in one where the conditions happen to permit observers. This idea is sometimes connected to the anthropic principle, but it remains deeply debated.
Here's the biggest problem. If another universe is truly separate from ours, how can we observe it? Normally, science depends on observation. You propose an idea, you make a prediction, then you test it. But if another universe cannot interact with ours, it may be impossible to test directly. However, physicists have considered possible clues. If another universe collided with ours during the early history of the cosmos, the collision might leave an unusual pattern in the cosmic microwave background. This ancient radiation is the afterglow of the early universe. Satellites such as COBE, WMAP, and Planck have mapped it with extraordinary precision. Scientists have searched for unusual patterns that might indicate something beyond our standard cosmological model. So far, no confirmed evidence of another universe has been found. That's extremely important. The multiverse is not an established observation, like galaxies, black holes, or the expansion of the universe. It remains a theoretical possibility.
Now we reach the idea that captured popular imagination. If there are infinitely many universes, could there be another Earth and another you? Mathematically, certain infinite universe scenarios can produce such possibilities. But this conclusion is often presented far more confidently than the science allows. We currently have no evidence that another version of Earth exists. And even if an infinite multiverse existed, whether identical copies of people would necessarily appear depends on assumptions about the number of possible states and how those universes are structured. So the idea of another you is not a scientific discovery. It is a speculative consequence of certain models. Still, it raises an extraordinary question. If reality is much larger than what we can observe, how much of existence could be permanently hidden from us? The multiverse also appears in some versions of string theory. String theory attempts to describe particles and forces using tiny vibrating objects rather than simple point-like particles. But the mathematics can allow an enormous number of possible configurations. Some estimates have suggested numbers as large as around 10 to the 500 possible vacuum states. Each configuration could potentially produce different physical properties. This is sometimes called the string theory landscape. It doesn't prove that 10 to the 500 universes actually exist. Instead, it shows that the mathematical framework may permit an enormous variety of possible physical environments. If some cosmological mechanism could realize many of these possibilities, a multiverse could emerge naturally from the mathematics. Again, though, possibility is not proof. So, is the multiverse real? Right now, science cannot give us a definite yes. We have strong evidence for quantum mechanics. We have evidence for cosmic expansion. We have evidence supporting inflationary ideas, although the exact inflationary model remains uncertain. But we do not have direct evidence for another universe. This distinction matters. A scientific theory becomes powerful when it makes predictions that can be tested. If a multiverse model produces observable consequences inside our universe, scientists can investigate them. If it predicts absolutely no possible observation, testing becomes much harder. That's why the multiverse remains one of the most controversial ideas in modern cosmology. Some physicists consider it a natural consequence of deeper theories. Others argue that an idea that cannot be tested should not be treated as established science. The debate is far from over. Imagine that one day, scientists discover convincing evidence, a strange pattern in the cosmic microwave background, an unexpected physical constant, or some unmistakable signature that cannot be explained by our universe alone. It would completely change our understanding of reality. Our universe would no longer be everything.
It would be one member of a much larger cosmic structure. The word universe itself would change meaning. Instead of asking, how big is the universe? We would ask, how big is reality? And perhaps our observable cosmos would be just one small region of something unimaginably larger. There could be universes with no galaxies, universes dominated by black holes, universes where chemistry never becomes complex, and perhaps universes with completely different physical laws. But there is one final possibility. Maybe the multiverse doesn't exist at all. Maybe our universe is truly everything there is. And that possibility is just as profound.